So I'm going over nomenclature and formula writing. And nomenclature is just like a systematic approach of naming compounds, and I will be using some rules that are what we need to use to name, like for example, ionic compounds or covalent compounds. So I'm starting here with a definition of what a compound is. And at this point, I'm sure you know what a compound is. And the definition of a compound, it's like when you have a different elements, okay, at least two different elements combined together, and those elements are held together by chemical bonds, then what you have, it's a compound. You can have different elements together, and if they don't have a chemical bond between them, holding them together, what you have is going to be a mixture, not a compound. So compounds can be classified into two main groups. We have ionic and we have covalent. For the difference between ionic and covalent compounds is the type of bonds that you have in your actual compound. When you have ionic compounds, electrons are being transferred. And what that means is that if the electrons are being transferred, something is losing, something is gaining electrons. And when something is losing electrons, you're going to get an overall charge that it's a positive number, because now your number of protons is going to be bigger than the number of electrons. So you do have an overall charge that it's a positive number. When something is gaining electrons, giving you a negative ion, now your number of electrons is going to be higher than the number of protons, and that's why you have an overall charge of a negative number. So if you have opposite charges and they attract each other, the attraction between your opposite charges is what's going to give you an ionic bond. So usually metals tend to form positive ions, and then non-metals tend to form negative ions. So the attraction between metals and non-metals, when they actually have a charge, is going to give you an ionic bond. And then I have a note here, NH4+1 and polyatomic ions, and I will come back to that after I introduce those to you. And then here on the right side, I have my covalent compounds, and in covalent compounds you have covalent bonds. Covalent compounds are also known as molecular compounds. So if you hear molecular compounds, we're talking about covalent compounds. In covalent compounds, we have sharing of electrons. There's no formation of ions, no attraction between positive and negative charges, because the electrons are being shared. So I have here an example of a simple covalent bond. If you have your diatomic molecule hydrogen, H2, your two hydrogen atoms are held together by a chemical bond. That chemical bond represents the sharing of electrons between your two hydrogen atoms, and that chemical bond is a covalent bond because you have sharing of electrons. Now also to review, I have here how we can assign the charge to an ion using the periodic table depending on the location of your element in the periodic table. My numbers here that I'm using to represent the groups, they might be different from what you can find in other periodic tables. Okay? I'm going to show you what I do. This is my main groups in the periodic table. I'm starting here with group 1, going all the way to here to group 8. 1, 2, 3, 4, 5, 6, 7, where you have your halogens, and then 8 for your noble gases. You might find like numbers in the periodic table using Roman numbers and letters. Okay, I just keeping it simple, 1 through 8 for the main groups, and then everything that you don't get to see in this part are your transition metals. So I have charge for group 1 as +1, group 2 +2, group 3 +3. Nothing for group 4. We don't use the periodic table to define a charge for group 4. And then we have 5, 6, and 7, -3, -2, and -1. For my positive charges, if you check your periodic table, mostly what you have in group 1, 2, and 3, it's metals, and then your non-metals, you have groups 5, 6, and 7 on the right side of the periodic table. So some examples here, the ion of sodium. Sodium is in group 1. Since sodium is in group 1, the charge for the ion of sodium is going to be +1. And then I have nitrogen here. Nitrogen is in group 5 in the periodic table. So the ion of nitrogen is going to be nitrogen -3. Polyatomic ions are like a group of atoms that it's chemically bonded together, and they are bonded together by covalent bonds. All you have in your polyatomic ions are nonmetals, but when you have them chemically bonded, you're going to have an overall charge. So I'm giving you a list here of some polyatomic ions. These are not the all of the polyatomic ions that exist. It's just some of them, the ones that we use more often. And you have to know the name, the formula, and the charge for these ones here. When you're thinking about polyatomic ions, you need to think about them as being a whole unit of atoms with an overall charge. For example, I'm looking here at my nitrate. Nitrate, it's 1 nitrogen atom bonded to 3 oxygen atoms. That's that 3 right there. That 3 that we use as a subscript, it's indicating the number of atoms that you have for that specific element. So the 3 that you have there next to the oxygen, it belongs only to the oxygen. You have 1 nitrogen because there's no number. So if you don't have a number, we assume that that's just 1. 1 nitrogen bonded to 3 oxygen. So that's a unit right there. A unit of atoms, all of that. And that whole unit, the entire polyatomic ion for nitrate, is going to have a charge of -1. So the charge -1 belongs to the whole nitrate ion. It's not just for the oxygen, it's not just for the nitrogen, it's for the entire polyatomic ion. So the same thing applies to all of them. Oxygen bonded to hydrogen, that's your hydroxide, and the overall charge for your hydroxide is -1. So the -1 is not just for the hydrogen or for the oxygen. The -1 belongs to the entire polyatomic ion. So if you check your list here, I have 1 positive polyatomic ion, ammonium on the top, and then I move to the -1s all the way to nitrite, and then I move to the -2s all the way to carbonate, and then lastly I have phosphate, which is with a charge of -3. 1 positive and all of those negatives. So in the previous page where you have your definitions for ionic and covalent compounds, right here I have attraction between positive and negative. Your metals from the periodic table, they're forming positive ions. NH4, your polyatomic ion ammonium, is the only positive polyatomic ion that you have listed. And then all of the other polyatomic ions are negatives. So your ionic compounds are always going to contain a metal or NH4 plus 1 bonded to a non-metal, or any polyatomic ion with a negative charge. So this positive part can be one or the other. It can be a metal or NH4, and this negative part in your ionic compound can be a non-metal from the periodic table or any of your polyatomic ions with a negative charge. So when you're trying to identify a compound as ionic or covalent, that's what you're using to find out if your compound is ionic or covalent. You're going to check your formula, and you're going to look at your formula to see if you have a metal or NH4. If you have a metal or NH4, that compound is ionic. If you don't have a metal or NH4 in the formula for the compound, that compound is going to be classified as covalent. So let's do some examples about writing the formula for ionic compounds. Things that you have to remember when you're writing the formula for ionic compounds: your ions by themselves, they will have a charge. When your ions combine, the positive and the negatives, the overall charge for your compound, it's always 0. It means that the number of positive charges that you're combining has to be the same total number of negative charges that you have. So ionic compounds, they are neutral. You're combining the positives and the negatives in a ratio that all of your positive charges, when you add them with the negative charges, you will get 0. What that means is that if you have an ion with a positive 1 charge, that one needs to be combined with one ion with a negative 1 charge. Positive 1, negative 1, they cancel out. Another thing that you have to remember when you're writing the formula is that in your formula, the positive ion always goes first. From left to right, you have positive and then the negative part. In all of the notes that I have, look, I'm writing positive on the left, negative on the right. Positive first, negatives after. Positive first, negative after. So it's always positive first or on the left side of the formula, followed by the negative part. So I have 2 steps here. You don't need to follow the steps. You just need to remember, when you're writing the formula, you're going to find the charge of the ions from the periodic table, and you're going to combine them in ratios that will give you an overall charge equal to 0. So if you're forming the formula for an ionic compound between sodium and Cl, Na and Cl, Na, it's in group 1 in the periodic table. Group 1, the ion of sodium will have a charge of positive 1. And then the ion for Cl, which is in group 7, it's going to have a charge of -1. So I have my 2 ions here, Na plus 1, Cl minus 1. My positive ion goes first, followed by the negative ion. Now, if you check the charges that you have, positive 1, negative 1. You have opposite signs, the same magnitude. Those 2 charges are going to cancel out. So 1 ion of sodium combines with 1 ion of Cl, and your formula will be Na and Cl, and that one is done. Whenever the charge of your ions is not the same, we have to use subscripts in the formula for the compound, so we can balance the charges. For example, I have here magnesium and Cl. Cl we already use, it's in group 7, so the ion of Cl is going to have a charge equal to -1 right there. The ion of magnesium, it's in group 2, so it's going to have a charge of +2. Now, when you're combining your ions in your formula, the overall charge needs to add up to 0. If you combine 1 magnesium ion with 1 Cl, this one is +2, that one is -1. So those 2, they don't add up to 0. If you add together +2 plus -1, that will give you something with a charge of +1. And your ionic compounds, they are actually neutral. So for you to have a proper formula for an ionic compound between magnesium and Cl, you need 1 ion of magnesium, that is giving you +2, and you need two ions of Cl. If you have 2 ions for Cl, that's -1, -1, you have a total of -2. 2 negative charges. And 2 positive charges, they add up to 0. So the formula that you get between magnesium and Cl for your ionic compound, it will be MgCl2. That 2 means that you need 2 ions of Cl combined with 1 ion of magnesium for you to have a neutral ionic compound. Here, the ion of potassium is K plus 1 because K is in group 1, so potassium, the ion is plus 1. Oxygen is in group 6, and the ion for oxygen is minus 2. Different charges, plus 1, minus 2. So for you to have a neutral compound between potassium and oxygen, 1 potassium is not enough because 1 potassium has a charge of plus 1, and plus 1 can cancel out only one of these 2 negative charges. So for you to have a neutral compound between K and O, you actually need two potassium ions. And that will give you a formula that is K2O. You need 2 ions of potassium combined with 1 ion of oxygen for you to have a neutral ionic compound. So I'm going to do this one without writing down all of that. Aluminum, it's in group 3. It has a charge of plus 3. Cl, it's in group 7, so the ion of Cl has a charge of minus 1. So you have 3 positive charges and only 1 negative charge. That remains as 1, but for your Cl, you need 3 of them. 3 Cl ions are going to give you a total of 3 negative charges that are canceling out with your 3 positive charges right there. So that's the formula between aluminum and Cl. Lithium plus 1, nitrogen minus 3. Group 1 plus 1, group 5 minus 3. For you to have a neutral compound between lithium and nitrogen, you need the same number of positive and negative charges. 1 ion of lithium, it's plus 1. 1 ion of nitrogen, it's minus 3. So you need a total of 3 positive charges to cancel out your 3 negative charges. And the formula should be Li3. 3 ions of lithium combined with 1 ion of nitrogen, it's going to have an overall charge equal to 0. Barium is in group 2, and phosphorus is in the same group as nitrogen, group 5. So the ion of barium has a charge of plus 2, the ion of phosphorus has a charge of minus 3. So 2 and minus 3. For you to have an overall charge that is equal to 0 in this case, you need 6 positive charges and 6 negative charges. You cannot add 1 positive charge to the ion of barium because that one is plus 2. If you add a second ion of barium, that will give you a total of 4 positive charges. If you add a second ion of phosphorus here, that will give you a total of 6 negative charges. So 2 and 3, you need to balance those 2 charges to 6. So to get 6 positive charges, you need 3 ions of barium. 3 ions of barium, it's 3 ions of barium, each one is plus 2. That will give you a total of 6 positive charges. Then for you to get 6 negative charges, you need 2 ions of phosphorus. that will give you 6 negative charges, 6 positive charges, and that should be the formula for your ionic compound that you're getting between the ions of barium and the ion of phosphorus. And then I'm going to leave that one for you to do between aluminum and nitrogen. And I'm going to write down something here that might be useful. M for the metal or the positive part. And I'm going to put positive because that's always positive. Letter A. A is an actual number. When I'm not writing a number, I'm just using a letter to represent that positive charge. The blue one represents the negative part in your compound. And for this one, I'm going to put minus B. So B represents the magnitude of your negative charge. A represents the magnitude of your positive charge. So A can be +1, +2, +3. B can be -1, -2, -3. So these are the ions that you're combining in a chemical formula. So you might find like somewhere, if you're using something else as a reference, that you can actually cross the charges that you have, and you will get the correct formula almost always, not always. So the charge for the negative here, it's minus B. So if you use B as a subscript for the positive one, and you use A as a subscript for the negative one, that will work to get the formula for many compounds. As long as A, it's different from B. If they are the same, you don't need any subscripts in your formula. If A and B are different, then you need a subscript. That's what we have been doing. When we wrote down the formula for NaNCl, you didn't need any subscripts because the charges were the same. A and B are the same. But then, when we started with magnesium and Cl, we have different charges, so we started adding subscripts to balance your positive and negative charges. So using the same one, that one here, magnesium is +2, Cl is -1. So if you see your formula here, you have Mg1 because that charge will be 1. And then you have Cl2 right there because the charge for your magnesium is 2. So when you're using the charges as your subscripts, you are not adding the signs of your charges. You're just using the magnitude of your charge or the actual number as a subscript. So you can see that that works perfectly fine for barium and P. Here, barium is +2 and 2 is the subscript that you're using for the negative one. And then you have your negative ion with a charge of -3, and that 3 is the subscript that you're using for the positive one. So in that way you can balance the charges. And we can actually use the same thing here for ionic compounds that contain a polyatomic ion. It also works. So I'm going to do a couple of examples with polyatomic ions. I have here sodium and hydroxide, and since you don't know the formula for your polyatomic ions yet, I'm going to write them down. Sodium group 1 + 1, and your hydroxide is OH -1. So sodium is +1, hydroxide is -1. You have exactly the same charge for your two ions. Since it's the same charge, you don't need any subscripts in your formula. This is Na, OH, done. When you have sodium and carbonate, now you have different charges. Sodium is +1, and your carbonate, CO3, -2. So when you're writing the formula for this one, remember the whole polyatomic ion carbonate has a charge of -2. Your sodium has a charge of +1. So for you to have the same number of positive and negative charges, you need two sodium ions. If you have two NAs, That will give you 2 positive charges and you have 2 negatives here. So the formula for this one will be Na2CO3. Your polyatomic ion carbonate with a charge of -2. Your 2 negative charges can be cancelled out with your 2 positive charges because you have two sodium ions in that compound. And then here I have another example. I have magnesium ions, that's magnesium +2, and hydroxide ions, which is OH -1. Not the same charge, it means that you need subscripts. 2 positive charges, just one here. Now you need 2 ions of hydroxide, not just one. If you have 2 ions of hydroxide in your compound, you're going to have a total of 2 negative charges that are going to cancel out with your 2 positive charges. So that part is not different from anything that we have done so far. What it's different is how we write down the formula when you have a polyatomic ion and you need a subscript different from 1. If you need a subscript different from 1 for your polyatomic ion, like in this case, for magnesium, you just need 1 because that's +2. But for your hydroxide polyatomic ion has a charge of -1. The whole polyatomic ion is -1, so you need 2 of them. So if you write down this here, your subscript, that is not the same at all as that. Right here, if you have something like this, this is 1 ion of magnesium, 1 oxygen atom, and 2 oxygens of hydrogen. Remember, like that your subscripts, they belong to the atom that they are attached to. 3 oxygens, just the oxygen, right? That 3 is not changing the number of carbons. That 2 right there belongs to your sodium ions, nothing else. So if you write down this is not saying that you have 2 hydroxides. This is saying that you have 1 magnesium, 1 oxygen, and 2 hydrogens. So when you have a polyatomic ion and your subscript for the polyatomic ion is different from 1, you have to put the polyatomic ion in parentheses like I did here. Now this is telling you you have 1 ion of magnesium and you have 2 hydroxide ions, +2 and 2 hydroxides. That will give you a total of 2 negative charges. You have the same amount of positive and negative, so that should be the formula for your ionic compound that you're getting between magnesium and the hydroxide ion. So I'm going to do one more and then you can finish those 2. The ion of aluminum, it's aluminum +3. Your nitrate, it's NO3 -1. Aluminum +3, nitrate -1. You have 3 positive charges, so you need 3 negative charges. 3 negative charges means that you need 3 nitrate ions in your formula. Since you need more than 1 polyatomic ion, I'm going to put them in parentheses with a 3. 1 aluminum attached to 3 nitrates. So the parentheses, it's only required when you're using more than 1 polyatomic ion in your formula to balance your positive and negative charges. And then I have your example here, the second one that we did for carbonate, the subscript was just 1. So you don't have to put carbonate in a parenthesis. You don't have to put your element in parentheses. What goes in the parentheses is your polyatomic ions whenever the subscript that it's required for your polyatomic ion is different from 1. So you have those two that you can do later, and you can ask me for the answers for you to check.